But today we will take a simple overview of bridge engineering. This is one of the most important field in civil engineering. So let's start it. So there are five types of bridges: beam bridges, arc bridges, suspension bridges, and truss bridges. So beam bridges is nothing but a simple structure supported by pier and based for short span. It is not based for long spans. Next is arc spans. It is designed like a curved design. It is effective of transferring the loads to support. Third one is suspension bridges. It is a long span with cable holding the deck and flexible strong. And last one is truss bridges. Uh, Truss bridges is constructed like a framework or inconvenient triangle, offering the high strength. So basically, the bridges are structures built to connect two places separated by obstacles like rivers, valleys, or roads. So bridges engineering is about the designing, building, and maintaining the bridges safely and efficiently. So the bridges are needed to make travel easier, safer, and faster. They help to connect the cities, roads, promotes the improve the transportation of peoples and goods. So without bridges, there are many routes would be much longer or inconvenient, in my opinion. So next slide is about components and their function. So there are, as we know, there are three types of components like superstructure, the part of the drive or the walk, that is, it is nothing but superstructure, and substructure is nothing but uh, support like pillars or piers or pillars. So, and third one is foundation, the bottom part that hold everything stable underground. So, uh, as well as the deck. The deck is nothing but the surface for vehicles and pedestrian disturbing the roads. Next is, as you know, as we discussed, the piers. What is piers? So next is bearing. Bearings allow controlment movement and reduce stress in the bridges. Next is foundation. This secure the bridges firmly into the soil or rock below. So the classification based on the bridges are classified based on their material is timber bridges, steel bridges, concrete bridges, and composite bridges. Timber bridges means it is made from wood. Steel bridges means it is strong and flexible. Concrete bridges means it is made from concrete and it is very durable. And composite bridges means it is a mix of material. So classification based on their shape and structure, like it is like beam bridges, arc bridges, suspension bridges, cable bridges, as we discussed earlier. And their classification of their purposes: road bridges, railway bridges, and foot bridges. Road bridges is for vehicles. Railway bridges is for trains and foot bridges is for pedestrian. So, last one is classification based on their span. So short span bridges, it is are up to the 20 meters. Medium span bridges means 20 to 100 meters span. And long span bridges, it is about 100 meters long. So the types of bridges is that's it. And the beam bridges. So the here it is slide explain about the class economical span and hydraulic situation. So economical span means the optimal length between support and minimize the construction cost. Means it is the economical. It is the length between two supports to minimize the construction cost. Means it is less durable as well as it is the cost will be span will be less. And next one is afflux. Afflux means water level rise upstream due to the bridge obstruction. Water level When water level rise, the upstream bridge will be the obstruction. HFL is nothing but high flood level. It is a maximum flood height to design a base for safety. Next is core depth. Depth of soil erosion. depth of soil erosion around the foundation and water. The so we need to explain this. It is a very simple. So next and most important part of the bridges in loads of bridges in IRC as per IRC load specification. So first is dead load. So as we know, the dead load is permanent weight of the bridges structure itself. And second is live load, dynamic loads from the traffic, pedestrian, as well as vehicles from the road, roads over the bridges. It is as per IFC codes. Next is impact load. It is an additional force from moving vehicles in dynamic effects. So uh, next is impact load. Next is impact load. It is an additional force moving vehicles dynamic effects. Wind and earthquake load. So environmental forces and wind and earthquake loads means it is environmental forces considered in design purpose. Means the wind and earthquake load also affects the bridge. Like if wind and earthquake load will fail, then bridge will be also fail. Next is about Oflux, SFL, HFL, and SCORDED explained in brief. So Oflux means, as we say, it is a belt of water level leading to flooding risk upstream. HFL means it is a critical for flood level, ensuring the bridge clearance and safety margin. And the SCORDED for essential for foundation design to prevent collapse from erosion. So next about this bridge failure in India. So first bridge failure in India is Percy Bridge failure. It is due to scar and flood damage led to catastrophic collapse in 2008. It is a huge mistakes of designer as well as technical mistakes will happen also, as well as Bandigunda Bridge collapse. It is for poor maintenance and overlaid causes failure in 2016. So, and third one is Rajendra Setu issues, the structural corrosion and inadequate stress distress. So my hometown is near about Satara, and as I know, the Savitri River over the bridge was also failed due to the poor construction and poor material use. The huge amount of people, also vehicles, was collapsed, and the people dead. So so the parameters also considered while making the bridge. So next is summary and future trends. So so um, um, while making a bridge, it is parameters also considered as an innovative material, like lightweight composite and high performance concrete are used for enhancing the durability. Next is smart monitoring. The IoT sensor enables real-time condition assessment for its safety. Use the sensors like measuring the flood level, measuring the uh, bridge failure cracks. The sensors helps to manage the cracks. Next is sustainability focus. It is an eco-friendly design for minimize the eco-friendly footprint. Next is improvement codes. The stricter IRC specification ensures safer and resilient structure. So basically, the bridges are an essential part of the infrastructure. Good bridges engineer ensure the safe, strong, and long-lasting structure. It's combined the creativity, science, and also practical. That's it. Thank you.